What is dopamine?
So dopamine is a molecule, a fairly small, fairly simple molecule that acts as a neurotransmitter. And what that means is, the brain consists of billions of brain cells called neurons, and they communicate with one another by releasing tiny amounts of chemicals across tiny fluid-filled gaps called synapses. And when the presynaptic cell, which is doing the releasing, uh, releases the neurotransmitter that stimulates receptors on the postsynaptic cell, it changes in some specific way the behavior of the postsynaptic cell. Maybe it'll make it more active, maybe it'll make it less active, maybe it will modulate it in more complex ways. And dopamine is one of these neurotransmitters, and not very many brain cells in the brain use it. I think it's 0.00005%. It's almost just a handful, but
Right.
what's amazing about it is that it projects all over the brain, and it sort of acts as a conductor, bring this up, bring this down. And by doing that, it has enormous influence over our thoughts, emotions, and behaviors.
Beautiful. I love the analogy of the conductor. And it is an astonishing fact that there really is such a tiny minority of neurons that do produce dopamine, right? That's maybe not something that penetrates the general population very often, because dopamine is probably the most known neuroscience word, yet only a really small fraction of neurons actually produce it. What makes it so important?
I think to answer that question, we have to look at evolutionary issues. The role of the body, and of course the brain is part of the body, is to keep us alive and reproducing. And there are many strategies that evolution has developed for human beings. Many of them are complementary, but some of them are competitive. And the competitive ones give us balance, sort of like the way the accelerator and a brake in a car act in opposition, but together they allow us to have fine control over the car's speed. So dopamine's role is to focus us on the future, and specifically maximizing resources in the future. And so dopamine makes us want things. It gives us the motivation and energy to pursue them. It gives us rewards, makes us feel good when we do things that make resources more likely to occur in the future. And that's what I think a lot of people understand about dopamine. But there's more. Dopamine also serves a more sophisticated function of allowing us to think in abstract terms. So the future doesn't exist in real physical terms. It's just imaginary. But what dopamine allows us to do is to imagine this future and play with it. We make models in our brain. What would happen if I did this? And I can give you an example. And I think an interesting example is actually dopamine in a non-human. Humans have the greatest density of dopamine receptors in their brains. I think second to that is a surprising animal. People might think of apes or dolphins.
Right.
It's actually corvids, crows, blackbirds,
Wow. That
yeah,
is interesting.
ravens.
I never knew that. You do sometimes hear crows being quite sophisticated with their behavior, but you're right that my brain initially went, okay, great apes, maybe dolphins. That's exactly where you leap to. Crows,
Yeah.
not so much.
If you look on YouTube, corvid intelligence, see some amazing videos. One example is the corvid is thirsty, and there's a glass of water, but it can't reach it because the water's too low. Can't get its beak down in there. So using dopamine, it makes a model of what's going on, and it can play what if scenarios. And by doing that, it picks up pebbles and it puts pebbles in the glass to displace the water and raise the level until it can drink.
Wow. That's
So
so cool.
that's what imaginary models allow us to do. A human example is I'm in Washington, D.C. If I want to go up to New York City, I can take the bus, I can fly, I can take a train. Bus is cheap, train is comfortable, airplane is fast. And I can sort of put myself in those different situations and see how I feel about it think about how it meets my needs. We might call that mental time travel. So dopamine not only makes us desire things and gives us energy and motivation to get them, it also gives us very sophisticated cognitive tools to make plans and work with abstract concepts like mathematics and the laws of nature to achieve those longer term goals.
Right. That's really, really well explained. Do we know how it does that? How it's such a master conductor of these really abstract ideas and concepts like, I want to improve my health. I want to get better sleep. I want to learn how to do computational neuroscience, whatever your goals are. I mean, the stepping stone to get to each of those goals is entirely different. There's going to be some overlap, of course, but they're so different. And dopamine is able to orchestrate those stepping stones and give you a clear vision of where to go. But do we know how? Like, how can it do such a complicated thing when it's only this, weird chemical group?
Yeah. Remember, dopamine is the conductor, not the musician.
Right.
So the tools that are making us do these very complicated things are the neurons in the prefrontal cortex. That's the part of the brain that's right behind the forehead. From an evolutionary point of view, it's the most recent development. It's in some ways what makes us humans. Humans have the largest prefrontal cortex. So what dopamine is basically doing is saying, use this tool. You got this tool. Now is the time to use it. And I think we can understand that better if we look at a psychiatric illness in which dopamine is not functioning well in that area. And that's attention deficit disorder. So people with attention deficit disorder have the capacity to focus, to use concentration, to organize things in an appropriate way, but their dopamine system is not turning these tools on. And so they're underutilized and they lie dormant.
Right.
If we treat them with a stimulant, such as amphetamine, methylphenidate, in the United States, the brand names are like Ritalin and Adderall. They're probably, yeah. That artificially turns up the volume on these dopamine circuits. And so now these tools are activated. So it's not dopamine doing the magic. It's dopamine turning on the tool.
Right. Right. That's more its function as a neuromodulator. It's controlling how circuits are working together.
Exactly. That's right. Yeah.
Perfect. Most people don't understand how dopamine works. That is just a fact. But luckily for you, you can click on my full-length conversation with Daniel Lieberman right now, and I actually promise you will understand dopamine better than 99% of the people. Remember, subscribe to the channel. Thank you so much.